Welcome everyone to the Thesis presentation event organized by PoliMi Data Scientists. I'm Alessandro, a member of the association, and I'll just take a few minutes of your time to introduce ourselves and our association, and then I'll leave the stage to the professors so we can start. Okay, what is PMDS? There are four main aspects in which we can define us. First of all, we are a community, and our main objective is to create a place where people who are passionate about data science can find a place to share ideas and work on projects, and in general create a chance for people to come in contact and know each other and share our common interests. We organize events alongside the companies where we call professionals of the field, which will give lectures or advice on the work of data science, on the professional life of data science. And we're also starting to organize more practical activities. For example, we are organizing some workshops where some big companies take some of their professionists and give you some little challenge and task to do to give an idea of what it's like to work at their company. And also, we are trying to create some projects, some real-life projects, and we will give you the chance to apply to work on this real-life project and can give you some more practical skills and something to add on your resume. Last but not least, we create and share the science resources. We have a newsletter, we have a blog, and also we have an open podcast where we give you the chance to have an open discussion with people from the industry. If you want to know more about us, we have a website. I suggest you to check it out. You can find all of our materials and a link to our social groups. In particular, I suggest to join our Telegram group where we post all of the news and content for the association. And stay tuned because we are organizing some interesting events in these days. A little spoiler, next week we'll have a talk with an ex-PoliMi student who is now working at Amazon, who will introduce you to the world of the cloud for data science. Okay, my presentation is over, so Professor Roveri, if you want, you can start your presentation.
Yes, thanks. Let me share my screen. Okay, can you see my screen?
Yes, we can.
Okay, at first let me thank you for the kind invitation. As usual, it's a pleasure for me here. It's also a pleasure for me to be here with Professor Boracchi, who is a colleague and friend, and we are working in the same group, providing the different aspects in the field of AI. I will try to be short and effective and start with the provocative questions aiming at addressing or trying to study what's next about AI. AI is widely known and well used, many different applications. What is interesting is to see which is the next big challenge, which is what we want to address in our research group. At first, let me describe what we typically do and which are the expertise of our groups. We are from the group of hardware, so from the group of computer architecture. So we grow in the field of new technologies, but we always add two souls, one related to technology and one related to the area of machine learning. So, and this is exactly the goal of the research. So combining the two approaches. So on one hand, designing new technological solutions where we can run machine and deep learning algorithms. So they take into account, for example, the Internet of Things devices, the edge computing systems, the cloud computing systems. And there we want to run new solutions typically based on the so-called machine learning and deep learning as a service approach. And on the other way around, we want to design a new algorithm, mainly algorithms be able to run pervasive devices in real-world scenarios. Hence, we have to design new solutions for being able to track evolution over time, being able to detect the changes in data that are coming, and as we will see in particular, being able to deal with sensible data. And this is a new research area in which we are working, where we want to process encrypted data by means of machine deep learning algorithms. But let me show you a couple of scenarios where we want to combine these technological and machine deep learning aspects. This is a scenario where we are running an environmental monitoring system. This is a system which has been deployed in northern Italy, in particular in the area of 𝗙𝗀𝘽𝗎𝗀. And this is exactly where the system is working. This is the Como Lake, and this is the town of 𝗙𝗀𝘽𝗎𝗀. Obviously, we cannot imagine having systems which are continuously updated or controlled by humans, but in such a challenging and harsh scenarios, we have to imagine systems which are able to autonomously take decisions, adapt to new working conditions, and being able to survive to changes, faults in the environment. This is exactly the scenario where we are talking about intelligence for embedded systems, tiny machine learning, or also called embedded and edge artificial intelligence. Here, the goal is to design new machine and deep learning algorithms able to take into account the severe constraints we have on energy, computation, and the memory of these pervasive systems, which are typically battery powered. So on one hand, we want to move intelligence as close as possible to where data are generated. And this is crucial to have autonomous systems, so systems which are able to process data locally, hence supporting real-time processing, real-time decisions. So decisions which allow to take fast reactions to events which might occur. Here we are also able to reduce the amount of data that we need to transmit because data are processed locally. And this allows also to increase the security and the privacy because being able to process the data locally, we are not required to transmit everything to the cloud, and hence being able to possible target of security attacks. So this is the scenario where we move AI close to the edge, so close to where data are generated. But on the other way around, we have also the scenario where, as in the introduction, we mentioned the fact that we have cloud and we have AI. Cloud and AI is a very good marriage because AI solution, and as we know, in particular machine deep learning solutions, typically require a lot of memory and a lot of computation, typically for the training and for the inference as well. And the cloud computing solutions can provide such needed memory and computation. So what we are seeing as a technological direction is the fact that we are combining machine deep learning with cloud computing, and this is bringing us to the so-called machine and deep learning as a service approach, where we are able, or where we want to design services which are able to provide in a fully automatic pipeline solutions to users which are not experts. So the expert is not, which the client is not, the user is not required to be an expert in the field of AI or in the field of cloud, but it is allowed to simply process data by means of machine deep learning solution, exactly as we use Gmail, as we use Dropbox, or as we use Google Cloud. In our group, we have the chance to bring things to the ground, working with industries in a real project, and this is an asset that then I will show you while describing the available thesis. But it is worth noting that from our perspective, bringing things to the ground with industries means that we want to provide innovation to industries. So theses made in conjunction with industries are meant to design new solutions, new products, new systems, which are novel from the point of view of the research. I mentioned a couple of activities that we typically carried out during the thesis. This is an interesting news which appeared on IEEE Spectrum last January, showing which is the importance of the competences which are requested by the US employers. As you can see here, there is a ranking made in 2014 and the ranking made in 2019. And please have a look at the change in percentage, showing that the one of the largest increase we have is in the competence of machine learning. And this is exactly why we are here today, because we are interested in the field. And this is exactly the increase in the competence machine learning, which is requested by US employers. As you can see, we have an increase of more than 400%. But in line with this, we have a similar increase in Python. And again, I'm fully sure that you are obviously aware of that. But it is also worth noting to see how relevant is the increase in all the other cloud computing platforms like AWS, Azure, or Docker, all the area of containerization and virtualization, with increases that goes from more than 400% to more than 4,000%, meaning that this is for sure a hot topic from both the algorithmic, the implementation, and the technological point of view. I would like to make a couple of comments about the state of the art in the field of AI. I will show you 3 news coming from newspapers, and I will comment about this in order to understand how relevant is the scenario in which we are working. This is the first news coming from the Corriere della Sera. And here the news, it is in Italian, but I'm pretty sure that you know, and I will translate it. Here we are, smart toothbrush, which are intelligent. Here the comment from the news is saying that we have the intelligence, but we don't need it. This is, I don't want to enter in commenting this specific news by the Corriere della Sera, but what is interesting from this perspective is the fact that often we are confused, or we confuse the term smart with the term connected, because what we typically use as name as smart something, smart toothbrush, smart shoes, or smart pen is typically connected pen, meaning that the toothbrush is acquiring some data, but the processing is not done locally. We acquire the data, we move everything to the cloud, and we have there the processing. This means that our toothbrush is not smart, it is intelligent, and the intelligence is then bring to the cloud, where we have the current intelligent, so the machine deep learning processing. This brings us the perspective of where we want to move our intelligence, and this brings me back to the points that I used for the starting. So where we have the intelligence, and in this scenario we have tiny machine learning embedded in edge AI, we want to endow our pervasive devices with intelligence, meaning that we have to move intelligence from the cloud to the ground, so to the IoT devices. The second example is again taken 10 days ago, roughly, from Corriere della Sera, saying that the smartphone is listening to what we are saying. I'm pretty sure that this is not a secret. I'm pretty sure that you all know that all the devices we have, all the smart speakers we have in our homes, they are listening to what we are saying. This obviously creates a great concern from the privacy perspective, meaning that we have to balance the access to intelligent machine and deep learning services with our privacy. It is not true that we have to leave or we have to neglect our privacy in order to access those services, but what we have to do is to design new services able to process data while maintaining the privacy of users. And in fact, one of the thesis area that I will show you refers to the ability to perform privacy preserving machine and deep learning. So designing machine and deep learning solutions able to take into account the constraints introduced by the privacy, so able to process encrypted data. The starting point of my presentation was why now? So what do we have for the next AI? I will comment that today we are here and you are interested in the field because we are seeing the perfect storm. The perfect storm between the markets, the data, and the pervasive solutions. So nowadays we have a market for AI. We have a lot of data such that we can process them to create the value of the data that we acquire, and we have a set of pervasive solutions, pervasive systems that allow us to process data from the real world. I would like to very quickly comment this perfect storm by providing three numbers. The numbers are 30%, 1%, and 5%. 30% means that there are interesting research papers that say that in the next few years, 30% of the activities will be carried out by automatic mechanisms. I'm not saying job positions, but making 100 all the activities that we do during the day. 30% of all the activities will be carried out in automatic mechanisms. This means that we must be able to understand which are these activities and be ready to transform these manual activities into automatic activities. And we could do that by using the machine and deep learning as a service paradigm, because we will have all these solutions which are pervasive in our world. The second number is 1%, which there is a very interesting research which is provided by Cisco, saying that only 1% of all the data which are daily generated by virtual sensors or real sensors are really processed. This means that we have a huge amount of data that can be explored, and in the future, the core will be the ability to integrate the data coming from different sources. For example, if we want to make a stock market prediction, I will not just use numerical indicators, so past value of the stock market, values of the macroeconomic indexes, but I will start using also the post and the tweets of the users, and maybe also the fact that a user is looking at videos on YouTube where we have that service or that product, such that we want to integrate all the information that we have while guaranteeing the privacy. And the last number is 5, because again, there are very interesting research that will say that in the next few years, we will have from 3 to 5 pervasive objects, which will represent our personal ecosystem in which we will work. It might seem rocket science, but if you think about it, we all have a smartphone, a smartwatch, and all the devices that we use for running, for swimming, for cycling. We are going towards that area. And here, the goal is that we have the person, the human in the center, and the pervasive ecosystem is enlarging all the abilities that the human can do in smart home, smart buildings, in health, in Industry 4.0, or in smart cars. So this is the scenario that we will have to face in the very next few years. And in this direction, these are the theses that I'm presenting. The first one is in the area of embedded edge AI, and here the topic refers to the tiny machine learning, federated learning, learning in stationary evolving environments, and zero-shot learning. Here, the goal of these theses is the design and development of new machine and deep learning solutions, allowing the inference and the learning, often the distributed inference and distributed learning of these solutions directly on the IoT embedded systems or edge computing devices. This thesis topic is carried out or can be carried out in conjunction with the company, which is 𝗔𝗕𝗎𝗄, which is supporting this research in 2 application areas, smart sensors in cars and smart sensors for elderly and health. The second topic is the topic associated to the privacy preserving machine and deep learning. Here, the goal of this research activity is the design of machine deep learning solutions which are able to process encrypted data by means of homomorphic encryption solutions. Here we have the encryption learning, approximate computing, AutoML for the design of such network, and even in this case, the topic could be carried out in conjunction with an industry, which in particular in this case, it is a spin-off of the Politecnico di Milano, which is called 𝗙𝗢𝗟𝗍𝗍𝗢. The third thesis topic is deep learning as a service for time series. This is in line with the activities where we want to combine cloud computing and machine and deep learning with the goal of designing solutions which are carried out, which are provided as a service. For example, we could design a service where the user just load through a JSON file, CSV, or accessing an S3 database of Amazon, and automatically the system creates, for example, in this case, through Flask in Python, a website providing insights of the data. And again, this type of thesis could be carried out in conjunction with the company, which is the spin-off the area. Okay, I think that I finished here. I hope I addressed some of the questions you have in mind. For those that I was able to manage, please feel free to ask. And I would be very happy also to share the presentation where you can find all the information and all the contacts.
Thank you very much, Professor. I think it was a very interesting presentation. I think you can either send the presentation to me via mail or Davide, or put in the chat.
Okay.
And also, we'll share the recordings with all the other students that couldn't be here today. So now, if there isn't any question, I think we can go on with Professor Boracchi.
Okay, it was a pleasure to everybody. Giacomo, the stage is yours. Enjoy and have a nice meeting, and have a nice day to everybody. Thank you again for the invitation.
Bye, Professor.
Bye.
Thank you for coming.
Ciao Manuel.
Ciao Giacomo. Ciao, buon pomeriggio a tutti.
Okay, can I start sharing?
Yes, of course.
Okay, let me check. Can you see that?
Yes.
Okay, so thanks again for the invitation, for the opportunity to present a few thesis opportunities we are opening now. And I'm just summarizing the major topics concerning the thesis opportunities that are currently opened. Then on the website here, you can see. On my website, you can find a PDF of this presentation, say, expanded with maybe some other thesis opportunity, and this will be also probably updated at the beginning of the next year. So if you're interested for a second semester start, for starting the beginning of the second semester, then you might have a look at the updated slides. So I just go straight to the topics where you might be interested in for a thesis, and because these are kind of, say, rather stable. So maybe the thesis opportunities are changing. For sure, the thesis opportunities are changing every year, but the topics are like close to these. So we got a few thesis opportunities related to deep learning, in particular deep learning for images or say point clouds. Now I'll give you more details about this. Then, I mean, there is a kind of quite a few say thesis opportunities related to computer vision and image processing. So all these algorithms for, say, not necessarily related to the deep learning, so even more like more geometric computer vision or pattern recognition problems, or as well as the image processing, image analysis technique, not necessarily to be solved by deep learning. Then there is kind of a different, completely different scenario where we have the change in the anomaly detection in data streams. So here you address different problems which are maybe more statistical, more related to data mining, where the issue is to detect when some data stream has a change. And then there used to be a few topics on machine learning for health that were done in collaboration with, in this case was Fondazione 𝗙𝗕𝗎𝗀𝗎. And now these are not open anymore. If you're interested in these opportunities, then maybe you might have a look at the slides in the future. So what I'm giving now in these slides, but I promise I will be rather quick. It's an overview of the background, so such that you can get familiar with what's actually needed to understand these, to tackle this thesis, let's say, so which is the background, and then some hints, which are the research directions. So in most of the cases, these theses are opened over active research activities, say active research between myself and PhD students of mine. Here you can see we are quite a few PhD students and some other collaborators that were former PhD students or say friends that are collaborating with us. So you can find also the names of those guys that are working together with us in the supervision of this thesis. And in general, for any inquiry, if you want, typically we arrange short meetings to discuss. If you're interested in some thesis, drop me an email. We arrange a short chat online, say a short meeting online, or a short visit to our office, and to see whether there is some thesis opportunity for you related to these topics. Okay, so let's start with deep learning. And the first problem with deep learning, let's say, now we are really looking for some champion for working on deep learning problems, say on deep learning model, to able to process point clouds. So point clouds, like here you see a face, like you can imagine these are points in the 3D. These are much more, say, difficult to handle than traditional images because these data are scattered in the space. So you don't have, like with images, you have a regular grid, and each pixel has a specific location inside your image, and let's say all the pixels are like acquired, referred to like a fixed offset or multiple of a fixed offset, right? So it's on a grid. Point clouds are instead scattered, and this makes things very complicated. So if you are familiar with deep learning, so you for sure know about convolutional neural networks. Convolutional neural networks are meant for this kind of data. There are, say, extensions of convolutional neural networks to handle point clouds, to handle graphs, to handle data with some kind of structure. In particular, we're interested in point clouds where there is no, say, edge connectivity, not even meshes, so really raw measurements like from laser scanners. And in these cases, what we have been designing with a colleague of yours, say last year, which is still with us working on the topic, we have been designing a different way to perform convolutions over point clouds, which is like illustrated here in this scheme. And so it's like a new layer, which is called composite layers, which is shown to have like compared to alternative layers for performing convolutions over point clouds, has some benefits. So it can be applied for classification, and it kind of reaches the state of the art. So it's comparable with alternative, but it's very effective in performing anomaly detection. So what we are looking for here is for a champion that can, I mean, expand this research in a sense that this definition is rather general, because there are like two different functions to be employed in order to perform this convolution. One is handling the points, having a different spatial arrangement, so in extracting information from the spatial arrangements of point, which is the spatial function. And then there is the semantic function, which is the information, which is the function extracting the information from the features associated to the points at the very input. So the first point is to kind of getting familiar with this layer and design new layers of the same family and address different tasks. So far we have been using anomaly detection, classification, possibly there will be open set recognition. There are plenty of other problems like saliency maps, so giving a hint and interpreting what are the regions in the image, or sorry, in the point clouds, providing the influencing most the network decision, the network output, and or like semantic segmentation as well over real-world point clouds, based on, say, starting from what we have now, which is this layer. And of course, this can be also used like in more fancy models like generative adversarial networks for generating point clouds. See, there are some works in the literature like this, but which are very recent. So you're welcome to join and address this problem, which is like, for us, it's very research-oriented thesis. Another problem we are addressing, if you feel so, please ask a question also directly while I'm presenting the thesis. Just unmute yourself, I'm happy to answer. Otherwise, we can do afterwards. The only problem is if you type in the chat, I might miss them. So if you really want to ask a question, just unmute yourself and ask. So another problem is related to robust adversarial attacks. So you know adversarial attacks, you know for sure that, I mean, this is like a very well-known illustration. So if you add a negligible amount of noise, you see the scaling number to this image, you can move the network, you can change the network prediction to the wrong class with even a large confidence, as it is shown here. So the problem is that these attacks are meant just for the digital world. What we are interested in is to study attacks and countermeasures to these attacks that are like effective when deployed in the real world. So like the issue is like the deployability. I mean, you can never add noise to some object such that it results like this exact kind of noise that perturbs the gradient in such a way to move the prediction of the network if the picture is being shot from a camera rather than feeding to your model directly the image you manipulate. So if you want to perform these attacks in the real world, you need to consider, like, for example, the fact that the attack has to be easy to reproduce. So there are only a few attacks in the real world that are easy to reproduce, like patch attacks, where you modify a square, a small square, which like a sticker you can paste over some target object. And this easily modifies the network prediction, or you can do scratches. So we are very interested in, say, we have an active research on studying how to draw some scratches in order to make effective attacks. And now the next steps is to study how to make these attacks robust to once they have been deployed. So it's not just a matter of just drawing a scratch over the image, but cover only, for example, a target where you want to apply your scratch, where you want to draw your scratch. So the idea is to assess and study attacks, including scratches or patches that are kind of have a limited support, and to make them easy to deploy in a sense that even if you don't exactly get the location, even if the picture is acquired from a different viewpoint, the attack is still effective. And together with studying the attacks, of course, there is the study of the countermeasures. So what are the countermeasures to be employed, say, on the network side in order to prevent these attacks to be effective? And we have already done some investigation, but are limited to the point of applying scratches or patches, like in this case, to the support of a traffic light, traffic sign, sorry. But I mean, there are no yet studies we did in order how to design the attack such that it is robust to, say, errors when in the displacement, such that when you go and draw it exactly over the traffic sign, is going to be more robust. And together with this, again, let me just remember, it's a matter of studying also countermeasures for this. In the slides, you can find more details about this. Another, say, thesis, it's open to object detection. Say, this is related to an industrial collaboration we should open very quickly. And we have been also supported by NVIDIA with another grant in order to train hardware detection, in order to train object detection networks over very large images. So if you take like object detection networks that are very popular, so you see here an example of what is a frame analyzed by YOLO. So YOLO, it's great. There are different versions, can analyze like nearly real-time, reasonably large images. But still, these images are like far from like 4K or high resolution images you get in medical domain or in X-ray images for inspection. So the idea is to bring this model to work over very large images, like for say security inspection and or X-ray machines, and at the same time. So another key point related to object detection network would be to address simultaneously also open set recognition. So determining whether there are some objects which are not meant to be background. So here, everything around is considered to be detected as a person, as a car, traffic light, a handbag, which are like those. There are a few dozens of known objects to be detected, and anything else it's considered a background. But there are studies like those reported in this paper, the second paper here, no, the first paper, that if you place another object like in very foreground, like an elephant, this object wouldn't be considered as background. It would be considered as one of the objects where the network is being trained to detect. So open set recognition, instead, it's the fact that your classifier can detect, can determine whether one of the inputs is not referring to those classes he has been trained for, but rather as a novel entity, a novel class. In this sense, it's called open set because as opposite to the closed set of labels of a classifier, where a classifier has a very fixed set of labels, or closed set of labels. Instead, open set includes also novel object. So these are like the two say, goals we want to investigate together with some champion among you in object detection, and also there is in both cases. And we are sure data augmentation will play a primary role. And then, okay, now I'm going quickly just to mention that we have a very active collaboration with Tampere University. And in this case, the deep learning is related to solving inverse problems in physics. So this is related to a project where, I mean, there are lasers producing a spectra. You can see some illustration of a few spectra here, different colors, different spectra. And the idea is to like draw, like I'm doing here with a tablet, a spectra, and by a neural network tell you what kind of parameter in some machinery producing these lasers, which is the supercontinuum generation. Okay, this is a specific machine, but say what parameters would yield a spectrum having those characteristics. So it's like a matter of solving, say, you got the forward model, which can be very well studied, where you can also simulate by either by physical devices or by numerical simulator. You have a few parameters, say theta here, that gives you a specific spectrum of a specific shape. We are studying by neural networks and deep learning model. We have already a paper in this regard, which I forgot probably to link, unfortunately, but you can find on my website, that solves the inverse problem. But this is not the only issue we are addressing. So together with some new energy, and this is solved by a colleague of yours last year, which is now in Tampere. And now the problem is to also generate spectra like this. So instead of using numeric simulation, which are like, okay, of course, very relevant, also to use these generative networks for signals in order to generate very realistic spectra. There are some works already done by the team there, which are not expert in machine learning. So if you are familiar with these, maybe you can for sure convey under our supervision definitely some good hint. So maybe just moving to computer vision, if there are no questions. In computer vision problems, we have been addressing like object detection quite a lot. Here is an example of software we have contributed in designing, say, the algorithmic backbone was entirely designed by us. And now a few companies like Bayern, I mean, through this, to a software house that was here in Milano. Now, these companies can just check by a single picture the entire shelf they have in a pharmacy to see whether what is being exposed complies with the, say, commercial agreement in terms of what kind of products having exposed and where. And I mean, this is done on the mobile device, and it's done really in a few seconds over like a large resolution image. It's done like in such a way that you can add and remove objects from your search, from the set of those you are searching for, like in very quickly, like just by adding a picture, no retraining needed. And this is like something we are very proud of, even though it's not. I mean, it's nothing earth-shattering from the research perspective. It's just some computer vision properly done, and but this also opens course for like more fundamental problem that if you are interested in addressing related to the domain of robust model fitting, where indeed each object, you can see there the detection of each object in this picture. It's related to of a fitting problem where you fit transformations between the scene and the objects and between some templates. And the robust fitting problem, it's a very fundamental problem in computer vision and pattern recognition, where you want to isolate your structures, which can be either planes, either planes in an image, planes in the 3D world, objects moving in a video, or 3D objects from different pictures of the camera. And identifying these objects is very challenging because you are affected by outliers, or what is called like pseudo outliers. So the fact that you got multiple models and instances belonging to each model plays the role of an outlier with respect to the others. And then you never know the fact that, so what is called the chicken and egg dilemma. In order to fit the model, say in this case, fitting straight lines, you need to segment the data, so and cluster them into group of points being consistent, but in order to cluster the points, you need to know what kind of model to fit. And this is a very fundamental problem. We are also using this in industrial collaboration, other industrial collaboration, but also say for more an algorithmic research, and in particular together with 𝗙𝗬𝗟𝗍𝗪, which is a colleague of mine, who is collaborating with me very, very actively. We are studying robust fitting techniques that are based on these preference embedding. So each point, so you can see in this illustration, each point is not looked at by its simple coordinates, but it's looked at after having like sampled several hypotheses, say several models fitting to the points. Each point is looked at from the preferences this model that have been fit conveys to the point. So you can see like here in this matrix, in each row, you can find a yellow or a color, a green, yellow, or a red square for those points that are like deemed to be in layers, say inside a band, in this case for the red model, for the yellow model. And I mean, this is a representation that is very effective and can lead to multiple, say, different algorithms that we use for fitting, say, models in data corrupted by outliers. This can be straight lines, but can be like 3D objects, or can be like images, or and their transformations in order to perform object detection. And we have been lately been studying how to fit multiple models together. Say in this case would be to fit either straight lines and simultaneously other kind of equations, analytic expressions like circles or parabola, whatever. And our idea is to move to use this approach. I mean, here there is a great tutorial from Luca, and you can have a look at that. And if you are interested in this, just out of curiosity, maybe then you can fall in love with this problem. And the idea is to use this instead of like with analytical models, as I was showing you before, with straight lines, planes equation, image transformations, which are also all allowed to meet analytical expression. We would like to use these in order to define what would be the best kind of clustering through many clustering hypotheses over the same space. So this is called like ensemble clustering or consensus clustering, and we are convinced that this can be well addressed by these preference embeddings, where each point is represented in a high-dimensional space. In this case, it's the row, which is the set of models that are actually where he is an outlier, so where he is consistent with. And we are, say, always that I'm concluding, always in the domain of computer vision, say, and 3D vision. We would like to, we are using deep learning as a way to solve like difficult model fitting problems or geometric 3D computer vision problems, by combining also deep learning information, say semantics that can be extracted from convolutional neural networks, in order to solve like traditional geometric vision problems that would nevertheless would be otherwise solved by traditional geometric approach. So our intuition is here that so we need someone that understands like basics of computer vision, that's familiar with computer vision, and at the same time of deep learning, because we want to combine the two approaches in such a way to take advantage of the semantic interpretation of the scene and to ease like the the search for geometric relations in 3D vision problems, in computer vision problems. Always related to clustering, let's say, and say pattern recognition, the idea is to introduce, say, to investigate explainable clustering solutions. By explainable, it's say this is something like might look very naive, but this kind of clustering, it's not interpretable in a sense that you don't have a simple expression for points belonging to each clustered item, while in this case, it's very clear. You can say that points belonging to cluster 2 have x2, which is between 5 and 10, and x1, which is between -10 and 5. And with a company we are collaborating with, this is like, you know, all those guys that are doing like fraud detection and or intrusion detection system that are still based on rule-based techniques, because when you want to say to block a credit card transaction, or you want to report some say serious issue, some accident, you need to have a good reason for doing this, and you need to know what are these. You need to be able to explain to experts why your machine learning model is making such a decision. So the idea here is to investigate clustering technique that works under simple schemes that can be translated by rules that are interpretable. And there has been like quite recent activities in this regard that are like very, I think it's even rather simple to address. And so if you are more like pattern recognition oriented, this is definitely an interesting problem that is worth studying. So in terms of explainability, even for simple clustering algorithms, because these are like very impactful then if you want to use these techniques in reality. Okay, I'm not presenting the thesis, but just to mention that we are also very active in the problem of detecting anomalies. Like this point is an anomaly with respect to the other that are like normal. This is say problem that underpins many say fraud detection systems or fault detection systems, and we have been working with anomaly detection techniques based on trees. Here you can find I4, which is a very popular. You can find it in scikit-learn. It's like a milestone work since say 2008 that performs anomaly detection. If you have to do some anomaly detection, I would say this is like the first tool to use at the moment. We also have our own tree that is built like so I4 is weird because it grows. It's a forest grown like by random split. Instead, we have a completely different approach where we have like a very unbalanced trees, as you can see here. It is called quant trees, and they grow like they grow like in only one direction. And this is very unbalanced. So it's say compared to like a KD tree, which grows balanced, it's not efficient in order to query it, but has the nice property, which we proved in this paper, where the statistics that you compute over this tree in order to perform change detection in this case, like are invariant of the distribution of the data. So you can guarantee like false positive controls, and we did a lot of work in this domain, also with a few PhD students of mine, both for monitoring data stream like in an online manner and just making decision one shot. And we have like now quant trees are made like by simple splits, like in this case, like straight splits. We want to study techniques to design quant trees like using kernels, such that we have like shapes that are like non-standard. We want to bring quant trees further in data stream analysis. We got very good ideas that we want you to investigate, and also applications to remote sensing. So if you're interested in change detection and data stream mining and anomaly detection, there is also plenty of say topics for these based on this work. Okay, I think I took a bit longer even than expected. I hope it's not a problem for you. If you have any question.
No, don't worry, Professor. We also finished a little bit early, so it's not a problem for the extra minutes.
Okay. Is there any question? Please feel free to ask. Don't be shy.
In the meanwhile, Professor, I ask also to you to share the slides, please.
Oh yeah, you have already prepared them here. Yeah, you can find the link on my. The slides are already on my website. It's better to look at them there. You can find even more slides I've skipped. And yeah, maybe some topics are say quite a few topics are already assigned, but you get an idea of what's going on, and maybe if you come for the next semester, there will be other thesis proposal related to the one that are already got. Say in terms of the topic wise, there can be some match.
Okay. Okay, if there isn't any more question, I think we can end the event here. Thank you so much, Professor, for joining us and presenting.
You're welcome.
And to everyone else, see you tomorrow for the last day of presentations. Bye, everyone.
Bye-bye.